Alright, hello, this is Dr. Marion Carroll again with South Central Louisiana Technical College. We started part 1, lecture number 9, talking about stoichiometry, and let's do an example or a few examples to help you with your own problems. The reaction I put up was sodium hydroxide plus sulfuric acid, giving us sodium sulfate plus water. Now, whenever given a chemical reaction, the first step is to balance. Alright? Very important to balance the chemical reaction. Alright, if you don't balance it, then you'll never get the correct answer, because as we talked about before, we're dealing in moles, and the coefficient that comes before each of the compounds in a chemical reaction is the molar amount of that chemical, molar amount of reactants. Okay, reactants are always on the left, and products always on the right. So how do we balance? Well, the best thing, and I kind of stole this from the internet from a colleague who set it up nicely, and it helps. Let me put this here and put the sulfur here, and it helps to that should have been hydrogen, sorry, trying to keep these in order. Sulfur helps you to kind of gauge where you are as you balance. So what do we have so far? We have one sodium atom on this side of the equation. We have how many oxygens? 1, 2, 3, 4, 5. 4 and 1. How many hydrogens? We have 2, 3. And how many sulfurs? We have 1. Alright, on the other side of the equation, under products, we have 2 sodiums. We have 5 oxygens, and hydrogens we have 2, sulfurs we have 1. So if we start at the top, and I recommend you start with elements other than hydrogen and oxygen. Sodium, we have 1 on one side and 2 on the other, so we're going to need 2 sodiums on this side. And we'll put a 2 right above sodium. So now we have 2 sodiums. Alright, they're balanced. Well, what did I shift when I did that? I shifted the oxygens. We have 6 now on this side. Hydrogens, did I shift the hydrogens? Yes, I have 4 now on this side. And how about the sulfurs? No, they didn't change. So now let's look at our balance. I have 2 sodiums, but I have 6 and 5. So I have 6 oxygens in my reactants, 5 on my products. We'll come back to that, because there's obviously a fractional number that I would have to place in front of sodium to give me equal amounts, or there might be a common multiple that I have to put on both sides. So we'll come back to oxygen. Let's look at hydrogen. Hydrogen, we have 2, 4, because of our 2 in front of sodium, we now have 4 hydrogens. And on this side, we have 4. We have 2. So we need 2 more to make this 4. Alright, and our sulfurs, well actually let's see what happened when we replace this hydrogen or the water with a molar coefficient. We now have 4 hydrogens, but we have 2 more water oxygens. So now I have 4 and 2 is 6. And finally our sulfurs. Did our sulfurs change at all? We have 1 over here and we still have 1 over there. So let's look at what we have. We have a 2 in front of our sodium hydroxide. We have a 1. Whenever you don't have a value, it's assumed to be 1. In front of the sulfuric acid, there's a 1 in front of sodium sulfate and a 2 for the water. So our balanced equation now is 2 sodium hydroxides plus sulfuric acid, 1, giving us sodium sulfate, 1 molar plus 2 moles of H2O. That's our first step. Let's do our second step. Let's put a first up there for our first step. Our second step is to convert our grams to moles. Okay, so in our problem, I didn't state fully, we have a reaction between sodium hydroxide and sulfuric acid giving us these products, sodium sulfate and water. And the problem states that the amount of sodium hydroxide I have is equal to, let's put it here, the amount of sodium hydroxide I have is 2.8 grams. Okay, that's how, this is what I was given. And the question was, how many grams of sodium hydroxide will I need to neutralize 2.8 grams of the acid? So neutralize, another way of saying react with. So, and essentially, how much sodium hydroxide will I need to completely eliminate 2.8 grams of sulfuric acid? And ultimately, we will make these 2 products. How much of these 2 products? That's not what our question is. The question is, how much of the sodium hydroxide do we need to neutralize the acid? Alright, so what I mean by grams to moles, well, if we're given grams, 2.8 grams of our sulfuric acid, we need to convert that into moles because we don't measure our reactions and their reactants in our products in terms of grams when we are calculating in stoichiometry. We only do it in moles. So where do we get, what do we do? Well, we want to set up our little grid here, because what we're going to do is we're going to convert these grams into moles. So we're going to need the gram molecular weight of sodium hydroxide. And where do we get that? We get that from our periodic table. Alright, our periodic table tells us that we have sulfuric acid, which has 2 hydrogens. The atomic mass unit, ATM of hydrogen, is 1.01. And we have 2 of them, so that gives us 2.02. This is the hydrogen. What about the sulfur? The sulfur has a atomic mass unit of 32.1. How many sulfurs do I have? 1. So 32.1. And the oxygen has an atomic mass unit of 15.99. How many do we have? We have 4. Alright, so if we multiply that, that's approximately 64 grams per mole. And these are the units for the atomic mass units of our elements. So what we do, we want to add that up, and we get 98.12 grams per mole. Now you notice the units are grams in our question, and the units for our gram molecular weight of sulfuric acid is grams per mole. So we want moles, so we need to set up our grid so that we can eliminate the grams and get our answer in moles. So what I do is I'll say 1 mole per 98.12 grams, which is the same as saying 2.8 grams divided by 98.12 grams per mole. Alright, the unit of grams is going to cancel out in both cases here. Grams cancel. It's just easier to see. H2SO4. It's easier to see in this grid mode. Alright, focus that. So if we did this math, what would we get? Trust a calculator here. Here it is. Alright, so if we take our number 2.8 and divide it by 98.12, our answer will be 0.03 moles. Okay, we have one significant figure over here and one significant figure over here. So it's alright to express this as express this answer as 0.03 moles. Alright, now that we have moles, what's the next step? Alright, well, step 3 is going to be the mole ratio, and I'm going to do that in part 2. I'll do step 3 and step 4 to get our final answer. And then I'll do several problems fairly quickly using a longer format that you would follow when doing your problems. Alright, we'll talk again.